Can you tell more about secure authentication and authorization workflow? So basically you need to answer in terms of advanced token management system, refresh token rotation, real-time revocation. So how do you tell your story? One of the critical problems I solved was around token lifecycle management. We had long-lived access tokens initially, which was a security risk. A leaked token could be used for hours. I redesigned the flow to use short-lived access tokens, which is 15 minutes with refresh tokens stored server side in Redis. I implemented a refresh token rotation scheme. Every refresh operation invalidated the old token and issued a new one. The token hash was stored in Redis with a family ID field. The name of the column is family underscore ID. If we ever detected the same refresh token used twice, indicating theft and replay, we immediately invalidated the entire token family and forced re-authentication. For revocation, I built a token block list in Redis with TTL equal to the remaining token lifetime. This gave us real-time revocation without the overhead of stateful session management on every request. Are the access tokens different from the refresh tokens and how are they different? So they are completely different artifacts with different purposes. So let's talk about access token. The purpose is to authorize the API calls, proves I can access this resource right now. Refresh token is purposed at getting new access tokens, proves I had a valid session and want to extend it. The lifetime of access token is 5 to 15 minutes typical, and the lifetime of refresh token is long, hours to days, sometimes 30 plus days. Where is the access token sent? To the resource server, the API on every request as authorization bearer token. Refresh token is sent to the authorization server's token endpoint, never to API. The format of the access token is usually a JOT, JSON Web Token, self-contained, signed, so APIs can validate it without a database call. Now refresh token, the format is usually opaque, random string. Its meaning is server side only. Now where are the access token stores? Client memory only, not local storage if SPA. And the refresh tokens are stored on server side state database or Redis and a secure client store. The access token is revocable or not. Hard JWT is stateless, need deny list or short TTL. Now the refresh token is revocable or not. It is easy. Just delete the server side record. What if the access token is stolen? Attacker has access for up to its TTL, which is 15 minutes. What happens if the refresh token is stolen? Attacker has access until detected major breach. An interview ready answer is an access token is the bearer credential that goes to APIs on every request. It is typically a short-lived JWT JSON web token, 15 minutes in our case, that the resource server validates locally with a cached public key. A refresh token is a long-lived credential, opaque rather than JWT, that goes only to the authorization server's token endpoint. When the access token expires, the client trades the refresh token for a new access token. The two have totally different threat models. Access tokens are everywhere on the network, so they have to expire fast. Refresh tokens travel rarely but unlock new sessions, so they need server side state and rotation. Now, next question, refresh tokens in Redis. Isn't that a cache? Won't they be lost? Now, this is a fair question to ask, and the answer is we use Redis with AOF persistence enabled and multi-AZ replication on Elastic Cache. So it wasn't a pure cache, it was a persistent store. The reason we picked Redis over Postgres was the rotation hot path. Refresh operations had to be atomic. Read the current token, validate it, mark it validated, issue the next one, all without a race. We did that with a Lua script in Redis in under a millisecond. The same operation in Postgres with select for update would have cost us 5 to 10 milliseconds and held row locks under load. The trade off we accepted was that in a worst case Redis cluster failure with backup loss, all active refresh tokens would be invalidated and the users would have to re-authenticate. Access tokens still worked until their TTL expired, so the user visible impact was bounded to a 15-minute re-login window. You need to remember Redis isn't only a cache, it's an in-memory data store. Whether data is durable depends on how you configure it. The interviewer is testing whether you understand the difference. Redis offers two persistence mechanism and you would use both for refresh tokens. One is AOF, which is append only file. Every write is locked to disk with append f sync space every sec. You lose at most 1 second of writes on crash. With append f sync always, you lose nothing but pay latency cost. RDB snapshots, periodic point in term dumps of the data set every n minutes. Production Redis for stateful data uses both AOF append only file for durability and RDB for fast restart. AWS Elastic Cache for Redis with multi availability zone plus automatic failover plus AOF enabled gives you durability close to a real database, just slower than the pure in memory mode. Now, but should refresh tokens go to Redis or Postgres? This is the actual architectural question. Both are defensible. Different shops make different choices. Redis pros sub millisecond reads, refresh operations are on the hot path. Native TTL support, token expires automatically without a cleanup job. Automatic operations, Lua scripts, rotation is naturally race free. Cheap to scale read traffic. Above are the Redis pros. Now Redis cons, persistence is weaker than Postgres in worst case crashes. If you lose Redis without backup, all sessions logged out. Redis is less suited for complex queries, auditing show me all tokens for user X. Now there are pros to Postgres, strong durability, point in time recovery. Postgres easy to query for audit and admin views. Postgres foreign keys to a user or tenant tables. The disadvantages of Postgres, slower 5 to 15 millisecond versus 1 millisecond for Redis. TTL needs a cleanup job for Postgres. Read scaling needs replicas for Postgres.